everyone, my name is Partho Das, Assistant Professor, Department of Electrical Engineering, JS College of Engineering, West Bengal, India. So, welcome to my class. So, as you can see, today's topic is stepper motor. So, we know that those stepper motor, reluctance motor, linear induction motor, so those are the actually different specials, they are under the category of special machines, because they have some different characteristics, some special characteristics. So that's why they are classified into the special machines. Okay, so this first we have to know what is the application of the stepper motor, then we are going for the constructional features, characteristics, those things kind of thing. Now, stepper motor. So, as the name suggests, so there is a thing of step. So, what is the step? So, sometimes we need that. Sometimes we need that the shaft of the rotor should not rotate 360 degree. Maybe we need the rotation of the rotor for 10 degree, 15 degree. So, there for those purposes, when we need a small rotation, so say there is a robotic arm. Okay, so now we want to rotate there is the arm, and we want to rotate that arm from this location to up to this location. So there a little angle is generating from this location to this location, start location to end location. So how can we do that? By this motor we can do that. Okay, so we in this kind of stepper motor, we have to provide some pulse into the machine, so that according to the number of pulse, it just shifted how much angle we want to rotate. But the point is that how we do that. Okay, so that thing we will do that. The what is the working principle behind that, what is the constructional features it has, so that it can do that. Then we have that what are the characteristics it has. So that means today's presentation is all about the stepper motor, which has a very angular, very important and very smooth angular movement, and very little angular movement can also be possible by using the stepper motor. So that's why it is a very important topic. So let us start with my presentation. Okay, so coming to the next slide. Yes, principle of stepper motor. So, stepper motor is an electromechanical device which converts electrical pulses into discrete mechanical movements. The shaft or spindle of a stepper motor rotates in discrete step increments when electrical command pulses are applied to it proper sequence. That means what I am telling, that thing is repeating over here. That means we suppose say we have to rotate a shaft or spindle of a stepper motor by some steps, by some uh, angle. So that time we can use by we can use the step this we can use some pulses to the machine, so that it can rotate that particular amount of angle or particular amount of steps. The motor's rotation has several direct relationships to this applied input pulses. The sequence of the applied pulses is directly related to the direction of the motion shaft rotation. The speed of the motor shaft's rotation is directly related to the frequency of the input pulses, and the length of the rotation is directly related to the number of input pulses applied. So, 2 points we can see over here. What are the points we can see over here? The speed of the motor shaft. The speed of the motor shaft rotation is directly related to which component? To the frequency of the input pulses. That means whatever input pulse we are giving to the system, that should have some frequency, and if the frequency is higher, then the speed of the motor shaft rotation will be higher. If the speed is frequency is lower, then the rotation of the motor shaft will be lower. Okay, input pulses, and the length of the rotation is directly related to the number of input pulses applied. That means how much it is going to rotate. That means it will rotate a total 360 degree. One complete rotation means we know that it is a 360 degree. So what should be the length. So it is 360 degree or 36 degree or 100 degree, 150 degree. So depends upon for the how much time, for the how many numbers of input pulses we are giving to the system, so that it can rotate. So two things we can say over here, that is the how fast the machine is acting, that will depend upon the frequency of the system, and how far it will rotate, that or how much steps it will rotate, that depends upon the number of pulses, the number of input we are giving to the system. So now coming to the next slide. Okay, so these are the types of stepper motor. So depending upon the constructional features, the stepper motors can be of three types. Okay, so those are variable reluctance motor, permanent magnet motors, and hybrid motors. Okay, so first of all, variable reluctance motor. Now you can ask me, what is variable motor, variable reluctance motor? So what is reluctance? So as in the case of electrical circuit, we know that what is resistance? Resistance is a component or the property of an element which opposes the flow of current, correct? So in case of electrical circuit, whatever is function is done by the resistance. In any magnetic circuit, reluctance perform the same works. That means it opposes the flow of the magnetic field. That means we can say, if the reluctance value is high, so there will be a lesser magnetic flux. If the reluctance value is very very low, then we can say that very very low, then we can say that there is a high huge magnetic field can be generated. Okay, and the permanent magnet motor. So in case of permanent magnet motors, what we do, over the rotor we have a permanent magnet slotted, so that we can make the different angles, different steps to make in case of motor. So we will later on we will going to see how the structures are made and how they works. Okay, and hybrid motor is the combination of these two properties. Okay, so coming to the next, these are the types of stepper motor we have. Now yes, this is the permanent magnet and hybrid stepper motor. So in the left hand side diagram, there in this particular picture, we can say that there are two diagrams. So in the left hand side diagram, it is showing us the permanent magnet stepper motor, and the right hand side diagram is showing us the hybrid stepper motor. So very interestingly, how this permanent magnet stepper motor works is that here, as you can see in the left hand side picture, so there is a rotor section, and over the rotor, as you can see, follow my pointer, there is a north pole, south pole, north pole, south pole, north pole. So like this way permanent magnets are placed over there. Okay, and over the periphery of the rotor, there is the stator section. Okay, so outer side we know there is the stator section, inside that we have the rotor section, and now in the rotor we are using like this way. So this is north south, like this way all the alternative poles are there. So this rotor section is a permanent magnet, and outer side of this machine, that is the stator section, we have the slots, and there we will give uh, electrical output. That means the stator poles are acting as a magnetic poles. Now what will happen, we will give the supply. So this stator alternative poles generating a north south north south north south like this way, and in the rotor section also we have the north south like this way. So we know that the same poles repulse each other, and the opposite poles attract each other. So depending upon this principle, this machine works. That means the attraction between the opposite poles. So suppose say this is the stator and this is the rotor. The stator has those slots and rotor has those slots. Okay, say very interestingly we can understand. So north south like this, and here also we have north south north south. So this is north, and here I am taking this say north south. Okay, so this one is the north, so I am taking that this is the stator shaft, north south, and these are the rotor shaft, north south. Okay, so the location of this two stator and rotor is like this way. Say for understanding. So this is the stator slot and the rotor set slot. Now when we are giving supply to the this stator section, electromagnetic section, so what will happen? So when we are giving supply, at that time it will be magnet. So when we are giving pulse to the system, so at that time we can say that this is energized. So now say this north pole will energize, say. So what it will do? It will attract nearby rotor's south pole. Okay. So say that rotor shaft is like this, rotor section is like this. Now when, and this is the south and this is the north. So when this north is energized, so whatever is the south is there, it will shift like this. Okay. So there is a shift of this little angle shifting like this way. Okay. So this is a permanent magnet stepper motor, and here as we can see, so the rotor teeth and the stator teeth all are very carefully slotted, so that when why this slotted are done to, so that the very little angle movement, a very one step movement of the rotor shaft can be made, so that so basic principle of the stepper motor is that the attraction between the opposite poles, okay, north and south. So obviously if there is a north, there is over the rotor, if there is a south, it will attract each other. Okay. So depending upon this principle, steppers motor are made. Okay. When to use a stepper motor? When we will use, well, let us see what is the answer. A stepper motor can be a good choice whenever controlled movements is required. They can be used to advantage in applications where we need to control the rotation, angle, speed, position and synchronism. Because of inherent advantages listed previously, stepper motor have their place in many different applications. That means what? Where we can use where we need a controlled movement, maybe in different industries, different robotic arms. So speed control, position control, synchronism control. So for the different purposes application we have for the case of the stepper motor. Okay. Now coming to the stepper motor characteristics. So what are the characteristics we have for in case of the stepper motor? Stepper motor are constant power devices. As motor speed increases and torque decreases. Okay. Steppers exhibit more vibration than other motor types, as the discrete step tends to snap the rotor from one position to another. Okay. So that means the stepper motor always have the higher frequency, the higher vibration other than the rest of the motors. Why? Because they are not rotated in a systematic manner. Say in the first, when we are giving some first pulse, it is rotated 10 degree. When the next pulse, 2 3 pulses are given, it is rotating 60 degree. So that means it is not a constant motion, constant step actually, not that always it is move in a constant step, it move in a discrete step. So sometimes it is, once it is stepped one step, sometimes it is moved 5 steps. So like this, so as per our need we can move that. So that's why there is a higher vibration rather than other motors. The vibration can become very bad and some speeds can be cause the motor to lose torque. Okay. So these are the characteristics of this stepper motor. Now we are coming for the torque equation. So the torque developed by a stepper motor depends upon the several factor. Okay. So what is the several factor? The step rate, the drive current in the winding, drive design, the basic relationship which define the intensity of the magnetic flux is defined by H is equal to N into I by L, where N is the number of winding turns, where H is the magnetic flux intensity, where I is the current, and L is the magnetic flux path length. Magnetic flux path length. Okay, that is very important, magnetic flux path length. Yes, it is very important point, that is the size and power of the stepper motor. In addition to being classified by their steps angle, stepper motors, that means according to the steps and angle, there is another classification regarding the uh, frame size, okay, which corresponds to the diameter of the body of the motor. Okay, for instance, size 11 stepper motor has a body diameter of approximately 1.1 inches. Likewise, a size 23 stepper motor has a body diameter of 22.3 inches, that is 58 millimeter, etc. So the body length may, however, vary from motor to motor within the same frame size classification. As a greater rule, the available torque output from a motor of a particular frame size will increase with the increased body length. That means, depending upon the output, if the output value is higher, then definitely the frame size will be higher. If the output is lower, then very lower, then the motor size will be lower. So this is obvious kind of thing, obvious thing. So power levels for IC driven stepper motors typically ranges from below a watt, so that level of in stepper motor can be made below a watt for very small motors to 10 to 20 watts for large motors. Okay, so the maximum power dissipation level or the thermal limits of the motor are seldom clearly stated in the motor manufacturing data. So that means, when we want to buy a stepper motor, so when we will collect the motor and we will take the motor in hand, so then we can find out over the motor we have some nameplates, so there it is written that what is the thermal limit. So there be each and every specification is there, not only in case of stepper motor, in all motors we have that kind of specification. Okay, so the rotating magnetic field. So when a phase wound of a stepper motor is energized with the current, a magnetic field is developed in the stator. The direction of this flux is determined by the right hand rule. The magnetic flux path developed when phase is energized with winding current in the direction the rotor then aligns itself so that the flux opposition is minimized. In this case, the motor would rotate clockwise so that its south pole aligns with the north pole and its north pole is aligned with the south pole. To get motor rotate, we can provide a sequence of energizing the stator winding in such a fashion that provides a rotating magnetizing flux field, which the rotor follows due to the magnetic attraction. So that means the basic principle is that what I am repeatedly telling you, that this magnetic attraction between the stator pole and rotor pole, that is the main funda for this kind of this stepper motor. Okay, so there are different kinds of pulses we can give to the machine, and due to that there are different kinds of states increment may be there in case of stepper motor. But the steps are achieved, how whatever is the number of steps are achieved by the magnetic attraction between them. Okay, so now this is the torque versus angle characteristics. Okay, so as we can see, in the x axis we have taken the angle theta, and in the y axis we have considered the torque. So but why representing the single characteristics between torque and angle, why we have taken two characteristics over here? So there are different reasons. So one is explaining the whole concept of this stepper motor, one is different levels holding torque levels are representing over here. So first we are coming to the left hand side diagram. So as we can see, there is a like sinusoidal waveform is representing. So when we are switching on a stepper motor. So at that time, with the change of angle, how the torque is changing, and with respect to that, which regions are stable, which regions are not stable. So that thing we can pictorially view, can we view in the left hand side diagram. So there we can see that. So follow my pointer. So this section, up to this section, this is the stable section. Okay, so up to this is an unstable section. Again, when it is going to be start, so that time again it is a stable section. So that means when rotor is start rotating, just start its motion, that time it is stable. Okay, so after it is reaching its maximum angle, when it is just reducing its angle. Okay, so the rest torque is going to be reduced. Okay, that means with the increasing value of angle, the torque is not continuously increasing. At after a certain point, it is again decreasing. It will go to 0. Again, if we increase the angle value, then it will be increased, but in the negative direction, it will negative maximum. So like this way, with the change of the angle, the torque is changing. And again, as we can see over here, with this is a holding one, holding torque 1, and it is holding torque 2. So different torque levels are represented in the right hand side diagram, and which is representing that the for the same load line. So what are the different angles are generating in case of the torque angle characteristics. Yes, now this is the torque versus speed characteristics. So here in the x axis we have considered the speed, and in the y axis we have considered the torque. Okay, so as we can see that when the speed is 0, the torque is highest, and when the speed is increasing, with the increasing value of this speed, the torque is decreasing, and when at a particular value it will be 0. So like this way, that means before starting before it is achieving any speed, it has a very high torque, and when it started, the torque is going to be reduced. That means a very high force is generated over the rotor, and due to that it's just shifted, and when due to that force, when rotor starts rotating in steps, so that time, so the torque value is definitely going to be decreased when it starts rotating. So that's why with the increasing value of the speed, this torque is going to be decreased. Okay, single step response and resonance. So this is a single step response versus time. So in the x axis we have taken time, and the y axis we have taken angle. So due to the input pulse to the system, the rotor will respond, and the response will be, initially it will be high response. So initially it will generate very high, with respect to time it will generate very high angle. Then when the torque value is decreasing, automatically this angle is going to be in a steady condition. Okay, that means whenever what if we continuously change the time, that means no change of the angle is there when it is going it is reached at its resonance condition. Okay, so advantages, let us see the advantages. So what are the advantages of stepper motor? Excellent response to the starting, stopping and reversing. It is possible to achieve very low speed synchronous rotation with a load that is directly coupled to the shaft. The motor's response to digital input pulses provides one open loop control, making the motor simpler and less costly to control. The motor has full torque at standstill. So these are the advantages we have in case of stepper motor. So now like we have some disadvantages. So what are the disadvantages? Resonance can occur if not properly controlled. That means it will no longer it will generate any angle. Okay, but it is not expected from a stepper motor. So if we don't look into the matter of the proper controlling of the stepper motor, so it will go in the resonance condition. So not easy to operate at exactly high speed, extremely high speed. Yes, definitely, as it is it has different steps angle, so it is very difficult to handle at a very high speed. So this is the advantage and disadvantages of stepper motor. Now we are seeing that the main thing where we can apply those things. The computer controlled stepper motors are one of the most versatile forms of positioning system. They are typically digitally controlled as part of an open loop system and are simpler and more rugged than closed loop servo system. Okay, industrial applications are in high speed peak and phase equipment and multi axis machines, CNC machines, often directly driven driving lead screws or ball screws. In the field of lasers and optics, they are frequently used in precision positioning equipment such as linear actuators, linear stages, rotating stages, goniometers, and mirror mounts. Other uses are in the packaging machinery and positioning on the value point stages for fluid control system. Okay, so commercially stepper motors are used in floppy disk drives, flatted scanners, computer printers, plotted slot machines, and many more devices. So there are various application, as it has a various range of variety in steps and speed and torque. So there are the different types of application we have in case of this stepper motor. Okay, so this is all about the stepper motor. So now I think you are now able to understand what is stepper motor, how they works, what are the different types of stepper motor we have, what are the advantages disadvantages we have for in case of stepper motor, and what is the application of stepper motor. Okay, so this is all for today. Thank you.